So today we'll focus our attention on application of differential equation. In our previous class, we learned two methods for solving differential equation. One is separable, two kind of differential equation that we learned in our previous class. One is separable differential equation. And the second one we learned is linear first order differential equation, which is the standard form of the equation is like dy over dx plus py equals q, this form. So in this kind of equation, what we did is we calculated the integrating factor, which is e raised to power p dx, and then we multiply both sides and we solve. Okay, that's the technique that we already learned. So we're going to use this skill to solve some of the real world problems coming from business and economics and social science. Before that, let us look at one concept, one idea, which is continuous deposit. What is this? An amount of money, A, invested at an annual interest rate R, compounded continuously, grows according to the differential equation given by dA over dt equals RA, where t represent time in years. And suppose that there are regular deposits made to the account at frequent intervals at a rate of $d per year. For simplicity, we assume that these deposits to be continuous, even though they are not continuous in the real sense, because you cannot put money on a continuous basis. But if you look at from an interval perspective, then it can be considered as continuous. For example, if you decide to put $100 every month for the whole year or for a couple of years, then we can consider that as continuous with respect to the month. If you decide to deposit, let's say $100 per year for many years, then we can consider that deposit to be continuous with respect to the year. Okay, so that's what we need to assume. Then differential equation for the growth of the account becomes dA over dt equals RA plus D. Note that this D is the deposit on a regular interval. It can be positive, it can be negative. If you are depositing into your account, if you are putting money into your account, then this means positive. If you are withdrawing, if you are taking out money from the account, then that D will be negative. Okay, you need to pay attention whether it's a withdrawal from the account or you are depositing in the account. If depositing, it's positive. If withdrawing, it's negative. All right, so with this concept, we can solve example 1 and 2. Example 1 is there and example 2 is here. So they are very similar. Maybe let's try example 2. Okay, and you will do example 1 on your own. Here is the question. When Michael was born, his grandfather arranged to deposit $6,000. So that is the initial deposit. Okay, when time is 0, that's the initial deposit. When time is 0, then the amount deposited is 6,000. If I change this into mathematical language, then that's how we can write. Okay, A of t, so t is 0. When t is 0, that's the initial deposit in an account for him at 5% annual interest rate. So the rate R is given 5%, which means 0.05. Change it into decimal. Compounded continuously. Now grandfather plans to add, remember the formula here is dA over dt plus, okay, the formula is dA over dt equals RA plus D. So that's the formula that we'll be using. So dA plus dt equals RA plus D. So what is D here? D is this 12,000 because grandfather plans to add to the account continuously at the rate of $1,200 per year. So D is $1,200. So we converted this information, English language, into mathematical language. Okay, we use the mathematical notation to represent the information given in the question. Now, part A, we are supposed to write a differential equation to describe the situation. So we know the formula here. So differential equation, I will write in short, okay, DE, differential equation to represent the given situation is given by dA over dt equals RA plus D, which means A is a variable, okay? Initially, it is 6,000. So after 1 year, it will be, 6,000 plus 1,200 and then the interest. In second year, it will change. Third year, it will change. So therefore, A is our variable, keep in mind. So now dA over dt equals R is 0.05 A plus D is constant, which is $1,200. Done. Part A is done. Okay, we change this whole English language, the situations, into mathematical form. Part A is done. Part B, how much will be in the account when Michael is 21 years old? For this, first of all, we need to solve it. Now, remember, we have the equation dA over dt equals 0.05A plus 1,200. We have this. Now, all we need to do is we need to solve this, find the general solution as well as particular solution. Now, there are two methods. For this particular question, you can use the separable differential equation method, or you can use the integrating factor method. You can use any one of these two. So let me take this all the way there. And first, let us try method 1. Let us use separable differential method first. Okay. So we have dA over dt equals 0.05A plus 1,200. I trust that you'll be able to solve it by yourself. Okay, let us work together though. So keep on working and I'll be doing here. And if you have any questions, just let me know, okay? Now, if you want to use the separable differential equation, because this is not difficult to separate, right? So what we can do is dA over 0.05A plus 1,200 equals dt. So that's it. Now, you know the formula. So the formula is, we know now we need to do the differentiation, integration. So if you do the integration, let's do in the second step, integrating both sides, you're going to get dA over 0.05A plus 1,200 equals integration dt. So this one will be, recall the formula, okay? We have learned the formula that integration of 1 over ax plus b dx is going to be 1 over a ln ax plus b. That's the formula, okay? But because this one is just the positive, it cannot be negative. So what you can do here is that it will be 1 over 0.05 ln and 0.05a plus 1,200. Okay, we can write this way. Absolute value sign is not required because we already know that this cannot be negative. It is positive. Therefore, you don't need to write that absolute value sign. This will be T plus C. So that means you can simplify now, just like how you do in pre-calculus. It's basically now high school algebra or pre-calculus. So we'll write 0.05a plus 1200 equals 0.05t plus 0.05c. All right. And now our goal is to find a here. So we need to exponentiating both sides. Exponentiating both sides, we're gonna get e raised to power ln 0.05a plus 1200 equals e raised to power 0.05t plus 0.05c. Okay, now you know the formula again. So a couple of formula here we need to know. So the formula that you learned from high school is this. If you have e raised to power ln x, then we can write simply x. So using that formula, we can write this as simply 0.05a plus 1200 equals, now using the formula, e raised to power x plus y can be written as ex times ey. So using this formula there on the right hand side, I can write this as e raised to power 0.05t times e raised to power 0.05c. Notice that this is just a constant, okay? E is constant and power this 0.05, C is constant, so that will be constant. This constant looks a little ugly, so to simplify or to make life easy, what I'm gonna do is I replace that by some other constant K. So now I will have 0.05a plus 1200 equals K e raised to power 0.05t, and where K equals e raised to power 0.05c. All right. Again, our goal is to find a here. So that means 0.05a becomes negative 1200 plus K e raised to power 0.05t. And to find a, divide both sides by 0.05, we're going to get negative 1200, 0.05 plus K over 0.05 e raised to power 0.05t. Okay, that's what we get. Any questions so far? Now again, this one is, you see, this one is another constant. K is a constant. When you divide constant by constant, you will get another constant. This constant looks ugly. You can leave it like this, not a problem. But to make your life easy, what I'm going to do is A equals negative 1200 divided by 0.05. I believe this one is 24,000 plus this one is, let's say, m e raised to power 0.05t, where m equals k over 0.05. So we got the general solution. Okay, this is general solution. Let me write this as equation 1 here, and this is called general solution. Now to find the particular solution, we need to find m, the value of m. How do we do that? Well, the given condition, look at the initial value condition. Here, initial value condition is given this one. This is our initial value condition. Let me just copy that here. So given we have initial value condition as a of 0 equals 6,000, right? This is the initial value condition we have. What it means is, this means when t is 0, your a is 6,000. That's the meaning here, right? So let us substitute that value in equation 1. So you're going to get 6,000 equals negative 24,000 plus m e raised to power 0. And this gives me m equals, can you tell me how much is that? M will be 24,000 plus 6,000, that is 30,000. All right. So substituting this value, therefore, substituting value of m in equation 1, we get a equals negative 24,000 plus m is 30,000 e raised to power 0.05 t. That is our particular solutions. Okay, this is called particular solution. So are we done yet? Not really, because we have to find how much money will be deposited in the account when Michael is 21 years old. That's the question. When Michael is 21 years old, that means t equals to 21. Substitute the value. So a equals negative 24,000 plus 30,000 e raised to power 0.05 times 21. And I don't have calculator. I need your help, guys. So can you please calculate this and let me know what is the answer? Type your answer in the chat box. Okay, all right. So thank you once again, everyone who responded in the chat box. And all of you got $61,729.53. Okay, that is the amount in the account after 21 years, when Michael is 21 years old. So the account will have this much of amount. So that's pretty good money, isn't it? Okay. Any questions so far? All right. Now, suppose we want to use, integrating factor method to find the solution, to solve this differential equation. And let's try that. Okay, method 2. So you have to use any one of the method. You can use this separable differential method. That's okay. But let's try using the integrating factor method just for fun. Okay, just for fun. So to use the integrating factor method, so let me just copy the question. So dA over dt equals 0.05a plus 1200. Now notice the standard form of linear first order differential equation is dy over dt plus py equals q. That is the standard form. Okay, but it is not in the standard form. So to change into a standard form, rewriting the equation in standard form, so we'll get dA over dt minus 0.05a equals 1200. Now you compare this with standard form, which is dA over dt plus PA equals Q. Notice that there is y in the previous example, that I mean in previous class, but our y is actually a here in this case. Okay, so I change that dy over dt into dA over dt plus py, py will change into pa equals q. Now all we need to know is what is our p-value. So p-value is clearly, this is negative 0.05. That is our p. So let us calculate the integrating factor. Integrating factor given by if, or you can write ix or whatever, it. So here it, because it is the function of t, is given by e raised to power p dt. So that's going to give me e raised to power integration p is negative 0.05 t. So that's going to give me e raised to power negative 0.05. Oh, not t, this is dt, sorry guys, this one is dt. So t, and you know that we don't write c there. So that is our integrating factor. Now we multiply both sides by integrating factor. Multiplying both sides by integrating factor, and so we'll get e raised to power negative 0.05 t dA over dt plus, not plus, negative 0.05 a e raised to power negative 0.05 t equals 1200 e raised to power negative 0.05 t. Okay, we multiply both sides by integrating factor. Now we know that when we multiply by integrating factor, the left side will be always d over dt and the integrating factor times this a. We already know that from our previous class. So equals 1200 e raised to power negative 0.05 t. Now all you need to do is integrate both sides. Integrating both sides with respect to t. So we're gonna get d over dt e 0.05 ta dt equals integration 1200 e raised to power negative 0.05 t dt. So the derivative and integration will be cancelled out. So you left with e raised to power 0.05 t a equals, this guy will be 1200 e raised to power, is that negative or positive? Okay, I believe this one is negative, right? So this is negative. Okay, this one is negative. All right, so you're gonna get 0.05 t over negative 0.05. Okay, that's what we get. Now if you want to find the this is negative again. If you find a is 1200 divided by 0.05 will be negative 24,000, and plus c, I forgot to write that c. This will be negative 24,000 e raised to power negative 0.05 t over e raised to power negative 0.05 t plus c over e raised to power negative 0.05 t. That's what we got. Now this looks a little ugly. Let us simplify it further. A equals negative 24,000, and this one cancel out, right? And plus this guy will be c e raised to power 0.05 t. That will be positive. Okay, this is our general solution. And you know how to find the particular solution, right? So to find the particular solution, to find particular solution, you have given the initial value condition, given initial value condition, which is a of 0 equals 6,000. This one is pretty much the same thing here. You just copy and paste. This part is same once you have this general solution. And what it means is 6,000 equals negative 24,000 plus CE 0.05 T is 0. Okay, and this gives me, if you simplify it, it's gonna give you C equals 30,000. So substituting value of C in general solution, GS means general solution, we're gonna get A equals negative 24,000 plus 30,000 e raised to power 0.05 t. That is your particular solution. Now, if you find when Michael is 21-year-old, so t equals 21, and you can calculate this easily. The same thing, a equals negative 24,000 plus 30,000 e raised to power 0.0521, and you already told me that it is approximately going to be 61,729.53. Okay, any question? All right, so we have already seen, we have done one example application problem by both method, separable differential equation and integrating factor method, and you can choose whichever you like. Now let's look at another application, okay, model of growth. So in this, one model of growth is unlimited growth, another is limited growth, and another is logistic growth. Okay, so these are the three growth model that we look into. I mean, basically we will focus our attention on the first two, unlimited growth and limited growth. These two kind of growth we will do in this course, and I give you one example for logistic growth, because for the logistic growth we need to learn a different method of solving the logistic growth function, I mean equation. So for that reason, I will just give you one example to look into it, but we will not do this in this course, okay? So first, let's try unlimited growth. What does that mean? If a quantity or population Y grows at a rate proportional that quantity size, then it can be modeled with unlimited growth. So there is no constraint, there is no restriction. Okay, and that kind of unlimited growth can be modeled with differential equation dy over dx equals ry in that form. Some example of this unlimited growth includes bank accounts, population growth, etc., if there is no constant. But if there is a constant, then we call it limited growth. We'll look into that later. Let us look at this example 3. A population grows by 8% each year. Okay, 8% each year. Let us write down the information in a mathematical way. So here R is given 8%, which means you can write 0.08. Okay, that is given. If the current population is 5,000, so that is the initial value condition. So initial population, we call it initial value condition, is a or y doesn't matter. You can choose a or y. Let's use y. Y of 0 equals 5,000. This is given. These are the two information given. Now we need to find an equation for the population after t years. So that means we need to find the particular solution. First, general solution and particular solution. First of all, let us model the situation. Okay. So differential equation that models this situation is given by, we know that dy over dx equals ry. Dy over dx, maybe we can write dt, okay, because we are talking about the time here. Dy over dt equals ry, and which means dy over dt equals r is 0.08 y. That's it. Now you can use the any method, so separable differential equation or the integrating factor, because in this case also either method works. So let us use separable, because I see that most of you like separable method when we tried by both method in the previous example. So let us use the separable differential equation method. So in that case, I'll write dy over y equals 0.08 dt. Okay. Now integrating dy over, let me go this way, integrating dy over y equals integrating 0.08 dt. So this gives me ln y is positive. You don't have to write the absolute value sign here because it's the population, right? Y represent the population. So you can simply write ln y equals 0.08 t plus c. Now exponentiating, I trust that you can carry on this yourself. Go ahead and try, okay? Complete this by yourself. This one is a constant. I replace that by k. So this is our general solution. Okay. Now to find the particular solution, then we must have initial value condition. So given initial value, which is y of 0 equals 5,000, this gives me 5,000 equals k e 0.08 t is 0, and so you're gonna get k equals 5,000. So therefore the particular solution is y equals, substitute the value of k in equation 1. Okay, substitute the value of k in equation 1, you're going to get y equals 5000 e raised to power 0.08 t. Okay, this is your particular solution. This is what we are required to find. Now, once we have the particular solution, and if somebody asks you what is the population after 10 years, well, it's pretty easy job now, right? You just substitute t equals to 10 and calculate. If somebody asks you what is the population after 20 years, well, t equals 20. You can calculate that way. Okay, any questions so far? So let us look at limited growth. Earlier, we look at unlimited growth. It means the model of the growth was such that there was no restriction. But now there is a restriction. If a quantity grows at a rate proportional to the distance from a maximum value m, it can be modeled with limited growth, which has the differential equation in this form. dy over dx equals k times m minus y, where k is a constant and m is a maximum size of y. So here is the example. Suppose when a product is advertised heavily, then guess what? The sales will tend to grow very quickly at the beginning, right? If there is a really nice advertisement and some product is coming into the market, at the beginning, the sales will grow so quickly, so rapidly, but after some time, the market will have some saturation point, okay, and the sales will slow down. So this kind of growth is called limited growth. Can you imagine some situation, some kind of limited growth situation where something like when comes to the market, the sale is really grow very rapidly, and after some time it just slow down. Okay, that's the limited growth type. And here is one example. A new cell phone is introduced. The company estimates they will sell 200,000 phones. That is their estimation. That is the maximum that they would sell, that according to their estimation. Okay, that's m. M is the maximum that estimations, which is 200,000 in this case. After 1 month, they have sold 20,000. What does that mean? After 1 month, they have sold, let us use our mathematical symbol. Here, m equals, notice that the model is this, dy over dx equals k times m minus y. That is the model. So m is given 200,000. Okay, we know that. And y of 0 is given, okay, at the beginning, nothing was sold. When time is 0, nothing was sold. But when 1 month after 1 month, how much is sold? 20,000. There are two initial value given. Okay, two initial value condition given. 20 sold. Therefore, what we can write here is that the differential equation that models the situation is given by the formula is dy over dx, not d, let me write dt because we are talking about time. Okay, dy over dt equals k times m minus y. So we have dy over dt equals k, m is 200 minus y. That is the differential equation to model the situation. Any questions so far? Now, in this case, all we need to do is solve the system, solve this equation. You already know how to solve it, and let us use the separable method. So it will be dy over 200 minus y equals k dt. Okay, so this is gonna give me integrating both sides. So you're gonna get 1, okay, negative 1 logarithm ln 200 minus y. That's what we get on this side, equals, this will be kt plus c. And so it will be ln 200 minus y equals negative kt minus c, right? So exponentiating, we'll get e ln 200 minus y equals e negative kt minus c. So this guy will be 200 minus y equals e negative kt, e raised to power negative kt, and plus e raised to power negative, not plus, times this one. Notice that this is a constant, okay? So this will be 200 minus y equals positive negative e raised to power negative c e negative kt, and so 200, I mean negative y will be negative 200 plus minus e raised to power c e raised to power negative kt. Almost done, guys. So now y equals 200 minus plus e raised to power negative c and e raised to power negative kt. Remember, I told you that this one is a constant, okay? So this one is I'll write this 200 this side, okay, 200 that side. So this negative will, this will be, and now positive 200, and so I can write y equals, let's say this one is m, not m. So we already used k is there, some other constant. What do you want to use that constant? Let's say a, e raised to power negative kt plus 200, where a equals positive negative e power negative c. Okay, so this is our general solution. Well, not yet. Okay, so because there are now two constant, a is also constant, k is also constant. So we need to find the value of these constant. How can we do that? So now, since we have two constant here, a and k, so we have two initial conditions. So with the help of these two initial conditions, we'll be able to find the value of both. So initial condition is given, initial value, y of 0 equals 0. So that means 0 equals a. Okay, remember what it means is when t equal to 0, y equal to 0. So I substitute that in this equation, y is 0, a and e negative k times 0 plus 200. So this gives me, what is the value of a? This gives me, well, let me do this. So this will be 0 equals a plus 200, which means a equals negative 200. Okay, a equals negative 200. That's what we got. So let us substitute the value. This is, let's say, equation 1, and substituting value of a in equation 1, so we get y equals negative 200 e raised to power negative kt plus 200. Okay, any questions so far? Now, this is our, let's say, equation 2. And again, given y of 1 equals, how much is that? 20? 20. So let us substitute that value. So that will be 20 equals negative 200 e raised to power negative k, t means 1, plus 200. So we will be able to find the value of k. So this is going to give me, solve it and let me know. Solving this, we get k equals, I'll wait for you guys. K equals what? Ln 9 over 10, how much is that? It's all high school algebra, guys. Pre-calculus, I believe you have done the exponential equation. So I need your help. Ln 9 over 10, how much is that? Or maybe, yeah, ln 9 over 10. Is that negative 0.10, negative 0.105? Am I right? So k equals 0.105. Okay, all right, so we are done. So substituting this value, value of k in equation 2, we get y equals negative 200 e raised to power negative 0.105 t plus 200. So that is this is our particular solutions. Oh, yeah, this is a really long answer, right? So it's fun though. A lot of high school concept we need to recall, high school algebra, pre-calculus, but I think you find it fun working on this. Nothing new concept, but it just takes a lot of time. That's it. So we are done with this concept. Like I said, logistic growth, we don't do this in this course. All right.